Welcome. Welcome to episode 1. Episode uno. The first episode of the OscopeWizard. I am Gabe, the OscopeWizard. That probably is obvious. And this is actually episode 1 Mark II, meaning it is my second attempt at this episode. The first time I did this episode was many weeks ago, and I looked at it and the sound was all messed up, and I thought, you know what? I'm gonna go back and fix that episode. And like any true engineer, I put it on the shelf, and then 18 episodes later, I finally decided today was the day to go back and fix it. So, if anybody can fix the past, it's a wizard, and here I am, the OscopeWizard. I'm going to try to do it. And we are going to use this time to nerd out. So the OscopeWizard show is all about nerding out about electronics and video games and engineering and having a good time, coming together, maybe even learning a little bit. That is always the hope, that we will end the episode slightly less ignorant than we began the episode. We always want to try to be learning. And it's going to last about 20 minutes, and we're going to explore some different topics in electrical engineering. So, in the spirit of staying on time, I've had some trouble in the past with staying on time. I have a timer, and I am going to begin it so that I don't lose track of time. When I get in a flow, sometimes I, occasionally have a tendency to lose track of time. Unsurprisingly, that happens to a lot of people in my field, and that is the field of technical sales, where my day job is. So yeah, we're gonna use the timer. We're gonna stay on track. Today, in the first episode of the OscopeWizard show, what I would like to explore is, well, goodness, where did it go? I had it sitting around here. USB signals, and I have hidden it from myself. How does a video game controller like this one get signals into a computer? Generally, a video game controller will use, if it's communicating to its regular video game, like its Xbox system, it'll communicate directly to the Xbox system wirelessly. And then somewhere inside that system, those wireless signals will be converted to USB signals. So this is a USB dongle for an Xbox controller. And I want to figure out what those USB signals look like, what buttons send what signals. So when you press the B button, your character jumps. But what underlying command was in that B button that the programmer used to tell the character to jump? So here is my wireless dongle that is with the controller. So before I get to the controller, though, I'm going to cheat a little bit today. I am going to use this start simple. So one thing that I have learned in engineering is the concept of KISS, which is keep it simple, stupid. Unfortunately, I've learned that over and over again because I always start simple, and before you know it, I have this super complex problem, and it's very hard to debug and diagnose and understand a very complex problem. But if you can keep the problem simple into small parts, then it's much easier to understand. So we are going to start very simply with a USB wireless keyboard. So this keyboard has a tiny little dongle right here, and we're going to plug this into our oscilloscope, which is what I am. I'm the OscopeWizard, and we're going to use an oscilloscope, which is a device that measures electrical signals, and I'm going to show you one, and we're going to measure the signals coming out of this USB dongle and going into the oscilloscope. So on that note, let us go over and take a look at our oscilloscope. So that's the oscilloscope screen, but I want to show you the setup. So here is the Raspberry Pi that we will ultimately end up looking at. For the time being, though, we are going to control our oscilloscope with our dongle. So we have the USB keyboard, and I'm going to plug this into the front of the oscilloscope into one of these USB ports, just like into your computer. The oscilloscope underneath is a computer, and this is my RTO oscilloscope. It's my favorite oscilloscope. I have used a bunch of oscilloscopes of all shapes and sizes, and I always find myself going back to this particular guy. It's like a favorite record or a really comfortable pair of shoes. Even when you get new shoes, you still go back to your old shoes just because they fit your foot so well. And this oscilloscope is a scope that I understand, I know how to use it, I really like it, and it does a lot of powerful things. So one of the things that you need in order to use an oscilloscope is a probe. So here is an example of the probe that everybody gets with oscilloscopes. It is a really basic passive probe. It has the clamp on the end, the hook, so that you can hook onto signals. And it also has the long ground lead. In general, the first thing you should do with the ground lead is take it off and get rid of it, because that is going to cause you no end of trouble, and you need to use short ground leads. But shipped with the long ground lead, that's super convenient because it's so long and it can clip onto a lot of different things, but it'll also cause you troubles in River City. You will notice that this dongle, though, looks like it is going to be a little bit difficult to probe. That is one of the struggles that you have in test engineering, is how do fundamentally I get the signal from my device into my test equipment. That is a struggle that will haunt your days for your entire career in the lab as you're trying to make measurements. Luckily, other engineers have also had this problem, and they have come up with solutions. So one of the solutions is to build a test fixture like this. And there are a bunch of different test fixtures out there that fan signals out. I have one such test fixture right here for HDMI. If you're familiar with HDMI, that's the connector that's in the back of your television, and generally the cable that costs way too much. You're like, why does this cable cost so much? I mean, presumably we're using millions of HDMI cables, so I'm not sure why it should cost 30 bucks. But this HDMI connector is just like a standard HDMI connector that you would plug your cable into on the back of your TV, and then it fans it out to the different test points, and you can now look at the signal of HDMI, which is your video signal. Similar idea here with USB. So I have a test fixture, and this is for what's known as compliance testing. Let me turn my light up so it's not so dark over there. There we go, a little more light. This test fixture is for compliance testing. Compliance testing is the testing that is done by a standards body in order to get the logo for that standards body. So we go over. I have the technology to show you more. I go over to my display here. I can see the Wikipedia page for USB. And here I can see the certified USB logo. In order for a company to print the certified USB logo on their box and to tell you as a consumer that, hey, we tested this. That's what that logo is all about. We tested this to a standard. It works. We guarantee it. Don't worry. If you buy this and you plug this USB device into any other USB device with this certified logo, it'll work. Thumbs up. If there's not a standards body, it gets a little bit crazier. And standards bodies can be super helpful for guaranteeing you, the consumer, that the device will work. So this USB keyboard is a certified USB keyboard. If I go back to my setup here, this USB keyboard is a certified USB keyboard. So it has been tested using compliance testing and using a fixture just like this. We're going to use this fixture, though, to just look at signals because, as I stated before, getting this probe connected to this little dongle, yeah, it's going to be almost impossible. Almost impossible. Now, if I plug this into my fixture, let's pick the right fixture. Let's pick, got to figure out, oh, here we go. Device signal quality. That's the fixture I want. Device signal quality. Come on, lamp. Help me out. Give me some light. Device signal quality right here. This is the one we're going to use. So I'm going to plug this. Instead of plugging it directly into the front of the oscilloscope like that, I'm going to plug it into this fixture. And then I'm going to plug my cable into the other side of it. If I can find my cable. Whew! Got my cable. I have my cable. So we are going to plug all of this together. And hopefully, when I get it plugged in, if everything is working properly, my mouse will talk to my computer. So, let's see if we can get my mouse talking to my computer. Mouse, talk to my computer. I always forget how I have to have these signals connected. All right. So now we have it all plugged in. Now to get the probe, how do I get the probe connected to this board? Luckily, hope is in sight. So first things first, let's get rid of this long cap. So this guy, we're going to pull that off. Get rid of that. And then we are going to get rid of the long ground lead because, as I said before, ground leads should be short. Ground leads should be short. I actually made a radio drama about probes that you can find on YouTube on the Rodian Schwartz website, the RNS 35 playlist. And it's all about using probes and how probes work. And one of the things we talk about is ground leads in that really weird radio drama. Of course, if I did it, it's going to be super weird. And longer ground leads allow more noise to sneak into your measurement. And noise is the enemy of good measurements. You want to keep your noise low because what you want to do is measure noise. You don't want to generate noise. You want to measure the noise. So one way to do that is keep the ground lead short. So I now have this handy dandy adapter which is designed to go right on these header pins. So USB uses a differential signal, meaning there are two signals. There is data plus and data minus, and we need to look at both halves of the USB path. And I can use my adapter, plug right into that header. And then I can connect my probe we can get everything working. Here we go. Here we go. Now we're cooking. I think we're cooking. I say that, and we're a little bit on the struggle bus. Let's try this side just to see what happens. I should be seeing my mouse move around. That's what I want to see. Why am I not seeing my mouse move around? Why am I seeing? Well, it'll help if I plug the dongle in. So let's get the dongle plugged in. Mouse, wake up. There we go. There we go. We have activity. We have activity on the scope screen. You can see it. My mouse is moving around. And we have my device plugged into my board, and we have the capability of looking at the signal. So let's plug this half in here. And I have a second probe up here, also with the little adapter, which is going to make it a lot easier on me to connect. The quiet silence is tough. It's tough. It's not tough on you. You're probably like, that's fine. I don't mind it at all. As a presenter, you want everything to go so well, and you practice, and then, despite all your practice, things can go wrong. So now I have two signals connected. That's a differential pair. Two probes are involved. As short a ground lead as possible. The whole system here with the probes is designed perfectly for this board. So my tools are working great. Let's look at the scope screen. As opposed to using a camera, we can actually look at the screen itself. So here is the scope screen, and this is what it looks like right now. First things first, when you're using any piece of test equipment, you should preset, because you don't know what was happening before. You can't guarantee that the instrument was used properly before you got there. Also, you might have forgotten what you were doing. Anytime you sit down to use a piece of test equipment that you weren't using before, preset. Anytime the piece of test equipment is doing something super weird that you don't understand, preset. It'll at least get you started at a place where you can understand the settings. So now I've preset, I have channel 1 on. If I go back though, you'll notice one thing that I did, which was, kind of funny. Ha ha, ha 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 ha. This is me laughing at my own jokes. I'm told you're not supposed to do that, but I put a pink collar on channel 1. So one of the things that I can do on the oscilloscope is change the color. So right now, channel 1, you can see right here is listed channel 1, waveform 1. It is yellow. So we could change that though to match the color that I've chosen. We have a whole bunch of colors we can choose from. We can use user-defined colors. That's a little aggressive. Or I can just select pink, and now it matches the collar. So now channel 1 is on, collar matches. I can understand what's happening. I can turn on channel 2, and I can cheat a little bit. So let me cheat a little bit by pressing the auto set button, and that'll scale the signal on the scope for me and at least get me in the ballpark of what I'm supposed to be looking at. Here we go. Channel 1, channel 2, looking pretty good. Looking pretty good. I want to focus on channel 1, so I'm going to drag channel 2 over here for the time being, and just check out channel 1, and let's see what it looks like. First things first, I can set up my trigger so that I'm triggering on channel 1, because that's the one that I'm wanting to look at. And I want to check out how fast this is going. So USB comes at different speeds. Let's see if I go back to my display. I think it talks about the speeds here. If I go to USB 1, yeah, so USB 1 released way back in 1996, before I even graduated from high school. And it started with a data rate of 1.5 megabits per second, which is pretty slow. I mean, for reference, today's USB 3 with the Type-C adapter can go 10 gigabits, which is mega, giga. That 10,000 times faster than 1.5 megabits, almost 10,000 times. It's way faster than USB 1. And that was low speed or low bandwidth. And then full speed came out. That was 12 megabits a second, a scorching 12 megabits a second. And then finally we got up to USB 2, where we hung out for almost 20 years at 480 megabits per second. How fast is my USB keyboard going, though? That is the question. We can measure it. That's what an oscilloscope does. So first of all, let me trigger on both edges, and that'll get what's known as an eye diagram. So if I look, I zoom in here, this is kind of a quasi eye diagram. What you have is if you can imagine, this is the opening of an eye. Like I'm blinking at you, like I'm winking. I'm not really good with winking with my right eye. Let me do my left eye. That's the eye shape. And that's what we see on the screen. We see an eye diagram. And I can make measurements on that eye diagram and figure out how fast the data rate is. So let's go into my measurements. Believe buried in these millions of measurements. So the scope does a lot of measurements for you. In the olden days, one had to make all these measurements with cursors. And in the modern days, the scope makes a lot of automatic measurements for you. But I think I might have chosen the wrong measurements. I might need to be over here into the jitter measurements. And let's see, data rate. Data rate, there we go. That's the one I want. Turn it on. Let's enable it. And let's set it up. Can I do, oh, there we go. Right off the bat, it says 11.9 megabits when I estimate the data rate for the CDR, which is a good sign. It means that most likely that my data rate here, whoa, oh my goodness.
5 minutes remaining!
5 minutes remaining, guys. 5 minutes remaining. That's all we have remaining right now. Let's see if we can get this measurement going, or a measurement going at least. So, zoom out a little bit. Ooh, here we go. This data rate measurement going to go for me? I might have to come back to the data rate measurement and use a slightly different measurement. I will admit, hopeful. I can say with some certainty that this guy is a full speed. Uh-oh, where did my scope screen? There we go. Wake up, camera. Wake up. Oh, and now we're gonna get the focus ring on here. Of course we are. There we go. Don't give me the focus ring, camera. Get your life right. So the data rate, when I turned it on, was showing me when I did the custom here, it says 11.9 megabits. That is great. That is solid. So now if I go back to my measurement setup, source channel 1, let's turn on some statistics. I think we could actually do the jitter wizard, and we'll do a TIE measurement. So I know that this is about 12 megabits because when I estimated it, found it. Now let's let it auto set and see if it can find out everything about this guy. Is that going to work for me, or do I need to delete that? Go in. Oh, you know what? I think I might be overthinking this a little bit. There we go. Do slope. There we go. Get our data rate going again. Overthinking it a little bit. Go back to time and there we go. I can do just a frequency measurement, and I can see that 6 megahertz, 2 times 6 is 12. There's my data rate. So I am running at 12 megabits. So this is full speed USB, not low speed USB. But that is the beginnings of USB testing. And that's how one would get a signal from a device like this little dongle. So from the dongle right here into the oscilloscope through some probes using a test fixture. The test fixture makes it so much easier. It's very important to use the right tools for the job. And so that's episode 1. We're going to keep going, though, into episode 2. We're going to start doing some decoding and some digital analysis because guess what? These signals on this oscilloscope, let's delete my measurements and get everything out of the way. Go back to just a single, let's do a single shot. So we'll single. Guess what? These pulses that are up and down, these are 1s and 0s. This is digital traffic. So this would be a 1, this would be a 0, a 1, 0, 1, 0, 1, 1, 0, 0. Actually, 1, 1, 1, 0, 0. That is how the actual data is being sent via USB, and really by any digital means. So HDMI, Ethernet, they all use pulses, digital pulses, to send the data. And we're going to decode those pulses in a future episode. And eventually, we're going to figure out what the B button sends when you press it. So what is the actual command that the B button is sending? Again, I am Gabe, the OscopeWizard. I don't know all the nerds in the world, but I would love to meet them. So please share this with the nerd in your life. And I will see you guys next time. Bye.